Good morning to all. Today we will discuss our new chapter, that is oscillation. All are well known about oscillation. जदि आमे दोली रे बसीचे ताले एटा होची दोली झुलिबा पेंडुलम झुलिबा एटा होची हमर ऑक्सिलेशन रो गोटे गोटे एग्जांपल. ताले ऑक्सिलेशन मोशन कौन ऑक्सिलेशन मोशन केमिति आमे गोटे बॉडी रो ऑक्सिलेशन केमिति करेबा तापाई कौन कौन एजेंट दरकार ता विषय रे आमे आज डिस्कस करें. सो इन ऑर्डर टू डिस्कस अबाउट ऑक्सिलेशन एट फर्स्ट we must know about periodic motion. So at first we will discuss periodic motion because oscillation is the part of a periodic motion. So what do you mean by periodic motion? The rotation of earth around sun, this is a periodic motion, or rotation of hands of a clock, this is also a periodic motion. Rotation of electron around nucleus, this is also a periodic motion. So what happens here? Why this type of motion is otherwise known as periodic motion? Because these are the example of our circular motion. ए एग्जांपल गुड़ाक आम सर्कुलर मोशन यूज करते तो ये पीरियडिक मोशन पुणी कौन पाई से एग्जांपल को आम यूज कले. व्हाट इज द डिफरेंस बिटवीन पीरियडिक मोशन एंड सर्कुलर मोशन? व्हाट इज द मीनिंग ऑफ पीरियडिक मोशन? ऑल ऑफ यू रिमेंबर, व्हेन ए बॉडी रिपीट्स इटसेल्फ, मे बी रिपीट्स इन ए लिनियर पाथ, मे बी रिपीट्स इन ए सर्कुलर टाइप ऑफ पाथ, बट रिपीटेशन मस्ट बी टेक्स प्लेस. व्हेन ए बॉडी मूव्स रिपीटेडली, if the example of motion of earth around sun, this is our sun and this is our earth. When earth rotating about the sun, always rotate in this way, west to east, then the rotation is repeated number of times and the time of rotation always remains constant. That means when earth rotates around the sun, it takes time 1 year or 365 days, and this time is always constant, and motion is repeated number of times or not. So these two concepts gives the definition of periodic motion. So how will define periodic motion? Now a body when moves repeatedly at an equal interval of time, or a motion which repeats again and again at regular interval of time is called periodic motion. And the time interval in which the motion is repeated is taken as time period. When earth rotated around sun, the time period is 365 days. If moon rotated around earth, then the time period is 28 days. If earth rotates about its axis, the time period is 24 hours, like this. Here the motion of the body takes place repeatedly with constant interval of time, with taking constant time interval. Then the type of motion is called periodic motion. Now taking the concept of periodic motion, we will discuss oscillation. Oscillation, or we may call vibration or oscillatory motion. Let's take the example, then we will define this. Let this is our rigid support. This is known as rigid support. Just take a string connected with a stone. Let this is your stone, this is your string. When you apply some force here, then what happens? This stone moves to this side. Let moves to this side, and again this stone return back. This is the initial position. Initial position. We may call this as rest position or mean position. Now when you apply some force, then it moves to outward, 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 then at last it goes to a fixed position, and from this position it cannot move to the outside, again it return back. So that upper position, upper fixed position is known as upper extreme position. Again when it return back, suddenly it cannot stop here. It again moves to back side. The back side position is known as lower extreme position. And the body, it moves this type with up from mean to upper extreme, then lower extreme, then upper extreme, then lower extreme. That means forward, forward as well as backward. The motion repeated forwardly as well as backwardly with constant interval of time at a particular path. Then the motion of the body is known as oscillation. That means simply you may call oscillation means to and fro or back and forth or forward as well as backward motion of a body about mean position is called what? Oscillation. So how we define oscillation? We can define a motion that repeats itself again and again about its mean position with well defined limit, that is extreme position, upper extreme as well as lower extreme is called oscillation. Or simply we may define, if a body moves to and froly or back and forth, to and fro means mean to upper, then mean to upper, then mean, then lower, mean to upper, then mean, then lower, this type through mean position. Then the type of motion is called oscillation. What are the examples of oscillation? Example of oscillation: vibration of string, vibration of swing, vibration of pendulum in a clock, beating of heart or heartbeat, beating of heart in a human body. Number 4, spring body system. This is your spring body system. This is spring connected with a body. One end is connected with body. This is your spring. Another end is connected with a wall. Then what happens? If we displace the body, then the spring stretched and again the spring also compressed. Here that stretching or compression of spring gives us the oscillation. Similarly, the vibration of prongs of a tuning fork. This is your tuning fork. A tuning fork has 2 prongs. These are known as prongs. When we vibrate the tuning fork, then the prongs are movement this side, to and fro. So this is also another example of our oscillation. But all of you remember, every oscillation is necessarily periodic, but all periodic motion need not be oscillatory. Why? We can explain this by using an example. Let's take the example. Motion of earth around sun. Here the motion repeated with constant time interval of 1 year. So the motion is what? Periodic. But is there earth rotating about sun to and fro? No. But rotation of earth around sun is not in to and fro or forward as well as backward. So we cannot take this example as oscillation. So we concluded that every oscillation having a fixed time interval, so it belongs to a periodic motion, but all the periodic motions are not belongs to the oscillation case. Now we will discuss the parameters connected with oscillation. Number 1, we will discuss amplitude. All of you remember, amplitude is denoted by A. This is plus minus A. So what is the amplitude? Amplitude is the maximum displacement. Maximum displacement means from mean. Mean means rest position to upper extreme. Upper extreme है plus A और lower extreme minus A position is known as amplitude. Number 2, cycle, or we may call oscillation. 1 complete back and forth. That means starting from mean position moves to upper extreme, then return to the mean position, moves backward to the lower extreme position. The complete path travelled by the body is known as oscillation, or 1 complete 2 and 4th motion of a particle starting and ending at the same point. At the same point, जो स्टार्ट होइथिबो सेठी आसी पहुंचबो. केमिति पहुंचबो? मानेकर मीन रु स्टार्ट हेछि, मीन रु अपर एक्सट्रीम को गला, अपर एक्सट्रीम रु पुणी कोठी के आसिला ना लोअर एक्सट्रीम को, पुणी लोअर एक्सट्रीम कंप्लीट करी जेतबेले से मीन रे पहुंचबो, जेति कि डिस्टेंस ट्रैवल करथिबो ताको हमें कोन कहबा ना, ताको हमें गोटे साइकिल बोली कहबा. इज कॉल्ड साइकिल. Number 3, time period, capital T. Time period is the time taken by a particle to complete one cycle. गोटे साइकिल कंप्लीट करबा पई जेतिकी समय नबा ताको जे टाइम पीरियड. यूनिट कौन ना सेकेंड. इट इज डिनोटेड बाय कैपिटल T and the formula is 2 pi by omega, because if this is the oscillation case, a body oscillate like this. This is the case of oscillation. This is mean, this is upper extreme, this is lower extreme. Then what happens? From this it moves to this part, then return to this, moves to this part and return here. So here it makes an angle of 360 degree or 2 pi radian. We know angular velocity omega equal to theta by t. Here angle is 2 pi and complete one oscillation means time period is t. So t is equal to 2 pi by omega. Then we discuss frequency. All of you remember the number of oscillation completed in unit time. गोटे सेकेंड समय रे गोटे पार्टिकलटा बा बॉडीटा जेतिकीटा ऑक्सीलेशन कंप्लीट करिवो बा जेतिकी साइकिल से मूवमेंट करथिवो ताको कहे कोन तार फ्रीक्वेंसी इज कॉल्ड फ्रीक्वेंसी. सिंपल से तुम कहबो कोन द रेसिप्रोकल ऑफ टाइम पीरियड is called frequency. F equal to 1 by T. Unit second inverse or hertz. Then we will discuss periodic motion. Periodic function. If you are taking the function f of t, the function which depends upon time is called periodic. And its value is repeated after definite interval of time. Repetition definite interval of time means first time period t changes, then 2t, 3t, 4t. If one time period the value of the function changes. That means if f of t equal to f of t plus 1 time period, f of t plus 2 time period, f of t plus 3 time period, dot f of t plus n time period, then this f of t is called what? Periodic function with time. Now we will discuss harmonic motion. When an oscillatory motion is represented by sine or cos function, trigonometry function, sine or cos function of time. जदि गोटे मोशन टाकू आमे रिप्रेजेंट करिबा साइन बा कोसाइन बा साइन बा कॉस फंक्शन ऑफ टाइम, देन इट इज कॉल्ड हार्मोनिक. These harmonic motion are of three types. Number 1 SHM, simple harmonic motion. Number 2 DHM, damped harmonic motion. Number 3 FHM, forced harmonic motion. In your course SHM is present. That means we are discussing what is SHM, how its equation depends upon cos function and sine function, what is the amplitude of SHM, frequency, velocity, acceleration, all about we will discuss the SHM. So what do you mean by SHM? First we will discuss. All of you remember In SHM, restoring force directly proportional to displacement. That means SHM means it is the simplest type of oscillation in which a body moves to and fro about mean position under the action of what? Restoring force. Our main concept is restoring force, which is directly proportional to displacement. If restoring force directly proportional to displacement under oscillation of the body, then it is called SHM. Well, first हम discuss करिबा restoring force काहाको कहाजे. The force which regain or restore, restoring ru restore a body from its new position to the original position. जेमती आम रबर को भिड़ुचे, रबरटा लंबा होची तले आम रबरटा को छाड़ी दौचे से पुणी जी लंबी थिला पुणी ओरिजिनल पोजिशन को पलि आमती जो प्रॉपर्टी बॉडी आम देखुचे ताकू कह जाए कौन ना इलास्टिसिटी आउ एटा कहा जो हुए ना रेस्टोरिंग फोर्स. सेमिति एसएचएम रे हमर कौन हुए ना जेते बेले आम जन को दोली रे बसेले ताकू आम आग को फोर्स देले ताले से मूवमेंट कला आग को तापरे से कौन करुची ना आपे आपे पछकू मूवमेंट करुची. ताले पछकू मूवमेंट करबा पई आमे ताकू किछि हेल्प करू नाही किंतु से मन को पछकू पछ आसुची. ताले जो फोर्सटा से दोली रे बसिथिबा मनिषटा को पछकू आणुची बा व्हिच रिस्टोर द मोशन, that force is known as restoring force. And in oscillation, restoring force takes the important role. When a body moves to offside, we make some displacement here. When displacement arise, then automatically restoring force comes into play, which tries to move the body from its new position, means extreme position, towards the mean position. So the type of oscillation in which restoring force is directly proportional to displacement. But all of you remember, displacement is always towards the forward direction, but restoring force always tries to move towards the backward direction. So the direction between restoring force and displacement must be opposite to each other. And the type of oscillation in which restoring force is directly proportional to displacement is called SHM. This is the definition of SHM. Now we will discuss what is the equation of motion of SHM. Let's take the explanation. For this case, we are taking the example of a spring body system. Let this is your spring connected with a body. Spring is a elastic body due to which restoring force comes into play. K is the spring constant. Initially, spring body system is in relaxed position. Now we apply some force, then what happens? The body displaces, body mass m. So this is the displacement. Displacement is x. Since the body displaces, the spring stretched. As a result, restoring force comes into play. This is the direction of displacement and this is the direction of restoring force. So by definition, F proportional to minus x. That implies F equal to minus kx. Where negative sign is due to opposite direction between force and displacement. And K is the proportionality constant. Called spring constant. Now K equal to F by X. ताको डिफाइन केमती करबा ना restoring force per unit displacement. But body having mass m and body also displaces, due to which we are acquiring velocity, and due to the changing of velocity the body acquire acceleration. So from Newton's second law of motion, F equal to how much? ma. This is your equation 1, F equal to minus kx. This is equation 2, F equal to ma. So from equation 1 and 2 we have ma equal to how much? Minus kx. That implies a equal to minus k by m into x. That implies a proportional to minus x, because k is constant, m is a constant. So k by m is a constant quantity. So from this we are again defined our SHM. Hence SHM is also defined as the type of oscillation in which acceleration is directly proportional to displacement and oppositely directed. Negative sign present here, so oppositely directed. Example: vibration of tuning fork, vibration of swing, vibration of pendulum, etc. Now we'll discuss the differential equation of SHM. In the next class. Thank you.